The box beam in the figure supports concentrated loads 2P and P. Compute the maximum allowable value of P if the working stresses in bending and shear are 1000 psi and 100 psi respectively. This is the profile of the beam and this is the section of the beam. The first step is to solve for the reactions in this beam. To solve for the reactions, we can use the summation of moments. First, we sum up moments about C equated to 0 and counterclockwise positive. So about C, we have a clockwise moment, which is RA, and this is directed clockwise. So we have negative RA times a moment arm of 5 feet plus 5 feet, we have 10 feet. Then about C, we have this counterclockwise moment, which is 2P, so positive 2P, times a moment arm of 5 feet. And then about C again, we have this clockwise moment of P, which is having a moment arm of 5 feet. So minus P times 5. And then equate it to 0. Then calculating, we can solve RA, and this is equal to 0.5 of P. Next, we sum up moments about A and equate it to 0, counterclockwise positive. So about A, the first force we can see is this 2P, and this is clockwise. So 2P, that will be negative 2P times moment arm of 5. The next force is the reaction itself. We have RC, and this is directed counterclockwise about A. So this is positive RC times a moment arm of 5 plus 5. So we have 10. Then lastly, this force P having a clockwise direction with respect to A, and the moment arm is 5, 10, 15. So negative P times 15. Equate it to 0. Using the calculator, we can solve RC to be equal to 2.5 P. So we label the reactions. RA is 0.5 of P and RC is 2.5 P. At this point, we are now ready to draw the shear diagram. So drawing the shear diagram, the first force we see is the reaction itself, RA, and this is 0.5 of P. So the curve goes up abruptly by a value of 0.5 of P. And then we can see no load here, so this will be horizontal. Then it goes down by a value of 2P. So 0.5 P minus, because this is going downwards, minus 2P, that will be negative 1.5 P. So minus 1.5 P. Then we see no load at this portion, so this will be straight. Then a load here goes up, or the reaction goes up, 2.5. So negative 1.5 plus 2.5, that will be P. And then we see no load, so horizontal. And then it goes down with this load, which is P. So P minus P equal to 0. That is our shear diagram. Next, we draw the moment diagram. The first point is a hinge, so this is 0. The second point is equivalent to the area of the shear diagram to the left of it. This is the second point. And the area of the shear diagram is 0.5 of P times 5 feet. So 0.5 P times 5, that will be 2.5 P. 2.5 P. Now, this is a straight line, horizontal straight line. So the degree is 0. Therefore, the moment curve is a first degree curve or a straight line with a slope. The next point is to be deducted by this negative area. So negative 1.5 times 5, that will be negative 7.5. Now we already have here the 2.5, so deduct it with negative 7.5. We can have negative 5 minus 5p. And then connect it again with a straight line. Lastly, we have this positive load. We have a value of p times 5 feet, so we can have 5p. Now this is already negative 5p. We add, because this is a positive area, so we add 5p, so we get 0. And this is now our moment diagram. Next, we now calculate for the stresses. And because the stresses are given, we have 1000 psi for bending and 100 psi for shearing. We can use the formula tau equals VQ over IB for shearing and sigma equals MC over I. First, let's calculate for the value of I. I is equal to BH cubed over 12. But our section here, although symmetrical, is hollow. So therefore, we need to deduct this empty or hollow portion. So I therefore is, first we use the big area and then we deduct later this one, the hollow portion. So B, this is 8 inches, 8, and then H is 10 inches cube over 12, and then we deduct it with the hollow portion. B is 6, H is 8 cube over 12, and we generate a value of 410.7 inches to the 4th power. Now we can use the two formulas to calculate for the value of P. First, we do in terms of shear. Before we can solve this one, we need to solve for the value of Q. Q is the first moment of area, AY. The area that we consider is the area above the neutral axis. So let me draw the neutral axis. This is located at the centroid of the section. Now notice that we have a positive area here and a negative hollow area here. So we just have to deduct. So the positive area is, this one is how much? 5 feet. We have 8, which is the base here, times height of 5, times the y, the distance from the centroid to the neutral axis. So here is y, and that has a distance of 2.5 inches. And then we deduct it with the hollow area. The hollow area has a base of 6, so minus 6, and the height of, this is 8, so therefore half of it is 4. 6 times 4 times the y. Now the centroid is located here, and this has a distance of 2 inches. So 6 times 4 times 2. And that will have a value of 52 inches to the fourth. Now substituting using this formula, our tau is 100 psi, so 100 equals, what is the maximum shear? In the diagram, the maximum shear is 1.5 P using the absolute value. So 1.5 P times Q, 52, over I, 410.7, times B. Now what is our B? B is here. So we have 8 inches and 6 inches. Therefore, we have 1 inch here and another 1 inch here. So the total is 2 inches. Then we have one equation, one unknown. We can solve for the value of P, and this is equal to 1053 pounds. Next, we use the criteria for bending, MC over I. The maximum moment is negative 5P using the absolute value, so we have 5P. The allowable stress is 1000 psi, so we copy 1000, and that is equal to MC over I. Our M is the absolute value, so 5P. Now remember, the unit here is pound-foot because our measurement for distance is in terms of feet. So therefore, to make it inches, we need to multiply it by 12. So 5P times 12. And then C. C is the distance from the outermost fiber to the neutral axis. So the outermost fiber is here and the neutral axis is here. Therefore, the distance is 5 inches. Over I is 410.7. Therefore, P can be solved, and this is equal to 1369 pounds. Now we have two values of P in terms of shear criteria and in terms of bending criteria. Now this one will govern because this is a lesser value. Thank you for watching.